Hi dear students, let's see this question that was asked in JEE Advanced Paper 2 numeric type. This was one of the easiest questions in whole paper 2, let me tell you, and I'm sure physics, chemistry, maths combined. Basically, there were very few easy questions in paper 2 and this was one of the easier questions. So most of the students would have grabbed this question with both the hands. This was based on Millikan oil drop experiment. Let's see what is given in the question. When the circuit is open, there is an oil drop which has some charge on it. It is falling due to its gravitational force, but it's falling at constant velocity, which is terminal velocity, because of the viscosity. So basically, viscous force must be balancing gravitational force. Once the circuit is closed, the charge or the oil drop that comes in equilibrium and it starts floating. That means we have to consider it at rest. So we have to find the number of electrons on the oil drop. So basically, it is given that the charge is negative because electrons means negative charge. So let us quickly analyze this question. But as I told you, this is a very simple question. So when the circuit is open, the gravitational force must have been balanced by viscous force. Viscous force must be acting in the upward direction, which would be balancing the gravitational force. The moment you the moment you close the switch, what happens? And the positive charge gets accumulated on the upper plate of the capacitor. The negative charge gets accumulated on the the bottom plate of the capacitor, and which sets up an electric field in the downward direction. Now, this electric field starts applying a force on the negatively charged drop in the upward direction, which starts retarding, or we can say which decreases the speed of the charged particle. Hence, the viscous force also decreases. So we can say that at equilibrium, the viscous force vanishes, and all we are left is with gravity and electrostatic force, which balance each other, right? Since the charge is negative, hence we can say that force on the electron must have been in the upward direction, which is quite obvious. So it's very easy, as I told you. We have to just balance the gravitational force with the electrostatic force, right? Let's assume that the number of electrons on the charge was n, which is what we have to find. The magnitude of the charge on the electron is 1.6 into 10 to the power minus 19, which is also anyway given in the question. So this is the total charge on the electron. The electrostatic field between the plates is simply the potential difference across the plates, which is 200 divided by the distance between the plates, which is 0.01. So this is the net force which is acting on the charge particle in the upward direction, must be balancing the gravity. So which is 4 by 3 pi r cube. R is given 8 into 10 to the power minus 7 whole cube. So this is volume into density of the oil is 900 into gravity, which is 10, given in the question. Hence, we can find the value of n over here, which on solving will approximately come out to be like very close to 6. Since it's an integer type question, so we can say that the answer must be 6, right? So now let me tell you this, the only thing that was difficult in this was the calculation over here. Rest everything was pretty easy. But yes, overall the question was easy. So I hope you would have enjoyed the solution. That's all. Thank you.